Hi everyone, welcome back to Maths Hub. This is our ongoing series covering all the topics and concepts necessary for you to ace the GMAT Focus Edition. In today's video, we will be covering the basic concepts behind ratios and proportions. Great, so now let's talk about the terms ratio and proportion, as well as another term which I feel is not entirely related but does seem to cause a confusion as to how they are related to each other, which is the fraction. Unless we really appreciate and understand the reason why mathematicians have introduced different terms, mathematical terms like these, we would not be able to completely do justice to any questions that these are presented to us. If you don't really understand and appreciate the question, you will end up putting together some random variables and some equations and trying to squeeze your way into the answer rather than fundamentally understanding the meaning, mathematical meaning behind the question. So let's dive deeper and really try to understand what these terms are. Now, a ratio is nothing but a comparison of two different quantities. Now, what do we mean by that? It's a way for us to convey that two different quantities are constrained or they are related to each other in a particular way. For example, this is how we represent a ratio. We have two numbers. In between two numbers, you have something like a colon, like your two dots, right? So the way you read this is 3:5. 3:5 is the way you read this, right? I'm going very basic here. If you are well-versed with it, you might as well fast forward or skip this video altogether if you are already good at the fundamentals of ratios, but this is for absolute beginners. So this is 3:5. Now let's take a real life example to understand what this 3:5 means. So let's, for example, say that we have a basket with some balls in them. So let's say we have 3 red balls and we have 5 blue balls. Right? So if somebody asks you what is the relationship between the red balls and the blue balls, you could say that the red balls are 3 in number and the blue balls are 5 in number. Right, so the relationship between would be, you will say that the red balls are in a ratio of 3:5 to the blue balls. So for every 3 red balls, you'll have 5 blue balls. So if you have to create, let's say somebody asks you to create this basket which is useful for 10 people. So let's say this basket is useful for only one person. So let's say you have to now create a basket for 10 people. Now you would simply multiply this number by 10 and this number by 10 and you will get a much bigger basket which has 30 red balls and 50 blue balls. But the ratio of the red balls to the blue balls still remains the same, which is 3:5. So ratio is a constraint. It is a mathematical relationship between two different quantities which relates them to one another. So if you could have the ratio multiplied by any number, right? So 3:5, 6:10. You could even have it multiplied by a fraction, right? So you could say multiplying both by half, you will have 1.5 is 2.5, right? So all these represent the same ratio. They are all the same ratio. And that is where you get the term proportion. So when you have two different ratios which are equal to each other, that's what a proportion means. A proportion is just two ratios which are equal to each other. That's all it is. So a ratio of 3:5 is the same, or this is more of a representation of, to say, is as to 6:10. So basically you're trying to say this weird symbol here is all that's trying to say is 3:5 is equal to 6:10. But now this might seem trivial, but it is really useful if the question represents something like you might be given a question where you say, let's say a ratio of 2:5 is the same as A is to, let's say, 6. Right, so in this case, what is being said here is that this ratio and this ratio are one and the same, are equal. So how would you try to solve this? We'll see how. It's actually very simple. So if you understand how a fraction works, right? So you can represent any ratio also in this format. Like you could also, twist this to 90 degrees and put a line over it and say it's just the same ratio, right? This is exactly why I wanted to clarify why it's different from a fraction, because representing ratios as a 3/5 or a 6/10 also makes sense. You can still say that there are 3 there are 3 red balls to 5 blue balls, right? You can still represent it this way, but the problem is this is not a fraction, this is still a ratio. It looks like a fraction, but it's not a fraction. So here we are comparing two different quantities. There are 3 red balls and 5 blue balls, but that's not what we do in a fraction. We'll get to that soon. Of course, we already know about it, but we'll still get to that and clarify it better. So now here you have a 2 by 5, which is equal to an a by 6. So what would you do in a normal situation, a fraction situation like this? You would cross multiply, right? You would multiply these and you would multiply these. So you would get 12 equals 5a, which means a equals 12 by 5. So if you plug that back in, what would you have? You would have 2 is to 5 is the same as 12 by 5 to 6, right? But ideally you would not want to have a fractional value inside a ratio. So what would you ideally do is you would cross multiply this, you would multiply both by 5 and you would say 2 is to 5 is the same or is as to 12 times 30, which is the same as multiplying this by 6 and multiplying this by 6, right? So a ratio always remains in the same constraint, but the number you multiplied is called a common factor. So any common factor you multiplied with a ratio, both the numbers you multiplied by the same number and you end up with a proportional ratio. And if you equate the two, that's where you get a proportion, right? So that's ratio and proportion for you. And now, even though we might represent ratios which look like a fraction, 3 is to 5 when represented as 3 by 5 does not indicate this is not a fraction. When you write 3 out of 5 as a fraction, you're trying to say that out of 5 things, you have 3 things. Like for example, out of these 5 blue balls, if you take away 3 blue balls, so 3 blue balls out of 5 blue balls were taken away. You're comparing similar quantities, right? So it's the same blue ball. Out of 5, 3 are taken away. So philosophically, the idea of a fraction and a ratio is very different. A ratio is trying to compare to the relationship between two quantities, right? So a number of blue balls, number of black balls, or the number of laptops to the number of mouse, or the number of kids, number of boys, number of girls. So it's trying to compare two different quantities and trying to give you the numeric relationship between these two quantities. But a fraction is trying to tell you how much of a whole quantity you have with you, right? So that is the fundamental difference. If you don't understand this, appreciate this, then you might fall into traps in questions. In mathematically, I personally prefer to work with a fractional representation, but always at the back of my mind, I always remember that I'm working with a ratio, right? So when you try to work with a ratio, let's say I was giving you an example earlier, let's take another example. So let's say this is a proportion, a is to, let's say, 9. One way to work with this is to multiply these two terms and multiply the outer terms, right? Multiply the means and multiply the extremes. It's a rule while you're working with ratios, but you don't really need to know that if you know how to work with fractions, right? It's exactly the same relationship. So when you have 3 by 5 equals a by 9, and when you cross multiply, right? So you get exactly the same thing. Do you see? See 5 and a is multiplied, 3 and 9 are multiplied. It's exactly the same thing, but just represented in a different way. Although this is exactly the same as how fractions would work, I'm trying to make you appreciate that the philosophical difference between a ratio and a fraction is different, even though mathematically you might work with them in the exactly same way, right? Okay, so let's talk about the next part. Okay, so now that we understand the basic idea behind ratios, proportions and fractions, let's try and see some of the scenarios which will be presented to you in terms of mathematical problems, right? So see, most of the time you will be given the ratio upfront, or will be told in the form of a word problem that the ratio of x and x is such. So you might be told that the ratio of a boy's age to a father's age is let's say about 7 times 10, or let's say 7 times 20, 7 to 20. So the boy's age and father's age is in the ratio of 7 is to 20. But does this mean that the boy's age is 7 and the father's age is 20? Quite unlikely, I would say. It's more realistic to say that the boy's age is 14 and the father's age is 40, right? Even though these two numbers are exactly in the same ratio, we know that realistically this is not the actual answer, but rather this might be closer to the actual answer, but we're still not sure. So most of the time, you would be in the position to by converting the given ratio into actual values using algebra, right? So how would you do that? Last time we spoke about common ratios, right? When you multiply any ratio by its common ratio, so 7 times common ratio is the ratio of 20 times common ratio. The ratio will not change. When you multiply the ratio by a common ratio, the ratio does not change. It's still the same ratio. It's still 7 times 7 is to 20, right? So this number could be anything. When you say anything, that's when you get the most famous symbol in math called x, right? So you'll always say that this is the same as 7x is to 20x. Right, so now you can say that the boy's age is 7x, right? And the father's age is 20x, because we don't know exactly what the x is, but we know that it is something, right? We don't know exactly x, the value of x, but we know for sure that the ratio of these two is the same. It's still 7 is to 20, but x may be 2, it may be 3, it may be whatever number, we don't know. But by representing using the common ratio and multiplying these two numbers, we can work with this now algebraically. And that is the core idea of almost any ratio question that you will be encountering. Any ratio question you will be encountering, first thing you need to do is assume a common ratio and multiply the rest of the terms with that. So let's say you have a question where you are told that L is to M is 7 times 7 is to 2 and X is to Y is 3 times 4 and yada yada yada. Doesn't matter how many such ratios you get, you always start with a common ratio. You will say P, but make sure that you don't have the same common ratio for everything, right? So it has to be different. You can never be sure that two different ratios are the same common factor, so always use different ratios. So here you can say that L equals 7p and M equals 2p. I hope you get that, right? So 7 times p is L and 2 times p is M. Now you might be confused as to how these two are equal, right? So it's always that first term is equal to the first term and second term is equal to the second term. That's why when you multiply these two and multiply these two, that is a different equation, right? So the terms are equivalent as corresponding terms. L first are corresponding, second are corresponding. So don't get confused there. And here you would say x equals 3q and y equals 4q, correct? And how many ever ratios you have, it's all the same idea, right? So that is how you work with ratios. You always need to first start with a common ratio and then you just multiply it to get the value that you need to work with algebraically. So we will be working with more questions in the coming videos, but in this session, let's just take the basic ideas behind ratios. Okay, so before we close the video, I just want to talk about certain examples in a real business scenario where ratios and proportions are not really used that much in actual business scenario because it's just about equating two ratios. But you might be hearing about this term called a P by E ratio, or a dividend to earnings ratio, right? So what is, if you're somebody who's into finance and stock market, you will hear about this term, right? So this is price to earnings. It's a price to earnings ratio, correct? This is dividend to earnings ratio. It's okay if you don't know these terms much, but I just want to give you a glimpse of a real world scenario or where these mathematical terms are actually useful, right? Most of the time we go to school and college and we don't really know what the hell we are learning about and where it's supposed to be used. But this is an actual practical scenario where this is being researched every single day. In fact, Warren Buffett, the most influential and the most successful investor of all time, this is a very common factor or a very common ratio that he looks at to analyze companies, right? So what is this price to earnings ratio? So price is the value of that particular stock in the stock market, is the price that he's talking about here. And this is the earnings. Earnings are the amount of money that the company has earned. So there is a particular ratio that the financial investors calculate and to understand the underlying value of the company. So usually they say that if this is more than 25, that the company is not very good state to be invested in. But if it is less than 25, it's usually an indicator that you can still invest in it and there is still room for you to make money there, right? So these are actual practical scenarios where you will be using ratios, and this is exactly why CAT, GMAT and all these management entrance exams need you to know these answers, need you to understand these fundamental topics of math, or else you will go to a finance class and you will go to a business meeting without understanding this, and people will not really appreciate that, right? So we will be deep diving into a lot of questions related to these same topics in the upcoming videos. So make sure you like and subscribe to our channel to be part of that. And let's together ace the GMAT Focus Edition. Have a nice day.